Hello friends, in this video we will learn how to do image in painting. Similar concepts can be used to do image out painting. But first let's see what is image in painting, right? Now let's say we have this image. Now we don't like some aspects of the image, or we want to change. Let's say we want to replace this pencil with a pen, right? Or we don't like this background, we want to change the background, so we want to keep the other objects in the image as it is. For example, we want to keep the rocket as it is, we just want to change the background of the image. Okay. Or maybe we want to keep the background as it is, so instead of rocket we want to have a car here. Or another example, imagine we have a monkey eating a banana, right? We just want to replace the banana with an apple. Okay, that's in painting. Or we want to keep the banana, but instead of monkey eating a banana, we might want to have a gorilla eating a banana. Okay, so that's image in painting, meaning we keep some parts of the image as it is, and we'll recreate specific portions of the image. Okay, that specific portions can be anything, right? We are going to control it using a thing called mask, where we can precisely specify which pixels should be kept as it is and which pixels should be recreated. Okay, so that's why it is called in painting. All right, so let's start. So here, as before, we have a prompt. Houston, here are a go for a launch. So I guess from this place they launch Houston's. So that has created this image. Okay, but this is not our initial image we are going to use for in painting. So we have slightly modified the image. We created a sketchy crayon drawing version of the image. Okay, we did similar thing when we created image using both text and init image, right? We are doing the same thing. So we just want to create a sketchy version of this image, which is this. Okay, so we start from here. All right, so we want to use this image and we want to do some in painting. Okay, again, just to be clear, this is not the image we are going to do the in painting. This is the image we are going to do the in painting. All right, so we have this image. Now in order to do this in painting, we will create a mask. So mask is another image with exactly the same dimensions, and the pixel values on the mask indicate whether that portion or that pixel should be recreated or leave as it is. Okay, for example, if we want to replace this pen with some pencil with something else, what we would do is we would create a mask of same dimension. So imagine we have another image with exactly the same dimensions, and we will have one color for pencil. So the mask is going to be a gray color image. So we will have one color wherever we have the pencil, and we will have another color wherever we don't have the pencil. So it's a binary type of thing. Okay, so using this binary image as a guide, we tell the model, hey, this is my image, use this mask to figure out which pixels should be recreated or do the in paint, and which pixel should be left as it is. Okay, so I hope you already know how the images work and the pixels, etc., right? So when we look at this image, it's 512 by 512 pixel, meaning, so here we have a pixel that has three values. Here we have another pixel that has three values RGB, the values between 0 to 255, And then here we have that 5/12 pixel, again with three values, represented by three values. The combination of these three values gives the color. Okay, similarly we can go down this as well. So we have total 512 multiplied by 512 number of pixels within this image. So we create a mask with the same number of pixels, but this time the mask will have a binary color. One color indicate whether something should be changed or recreated. The other color indicate what should be kept as it is from the original image. Okay, so here we are taking this image. Okay, we are taking this image and we have converted it to grayscale image. Okay, so the grayscale image looks something similar to this. Okay, now not exactly this, because we have did some modifications. Okay, and then we converted the grayscale image to an array, to a numpy array. Now the trick here is this part. Okay, that we are basically binarizing the image. Okay, now this value 150, so this gray image will contain values between 0 to 255 for each pixel, right? So whereas here we have three values representing each pixel, but when we convert to gray, the three dimensions, the color dimensions become one, because we have only gray color, and each pixel will have a value between 0 to 255. Now you can look at the values of those pixels, and when you have some understanding of the colors and the numpy arrays, etc., you will find out that this whitish part of the image will have pixel values higher end, right, on the higher side, whereas these parts of the image has pixel value on the lower end. So roughly around 150. It don't have to be exactly 150, but what we are doing is this grayscale image we are binarizing. So what we are doing is we are replacing the values wherever the value is less than 150. We are replacing that value with 0. Okay, so all the values, all these values, okay, except this rocket, these white colorish pixels have a value of 0. Okay, so that area or the region we use for inpainting or recreating the image, whereas all the pixels with value above 150, which is these values, the white color ones, okay, the white, these ones, so all these pixels we are replacing with value 1. Okay, so at this point we have a new gray color image which contain only two values are binarized. Wherever the rocket is, that will have a value of 1, and the rest of the image will have a value of 0. So the 0, that's the inpainting region. 1, that's the region we are not going to touch. Okay, and then here we are doing a bit of manipulation, so we can control the strength. So the inpainting region is going to be guided by a text prompt we provide. Now again, the prompt, we can provide some weightage, right? I mean, do we want to this inpainting region to be exactly followed by the prompt, or do we want to leave some flexibility to the model for creativity, etc., right? So here we are choosing a strength, and again with this manipulation we are simply scaling the values which are 0 to 1 back to 0 to 255. Okay, so the mask will look like this. Okay, so in this mask the whitish pixels going to remain as it is, the grayish pixels are going to be recreated. Okay, now this is not so much important. So when we do the inpainting, we don't want very sharp edges, right? Meaning, for example, here we are saying this pixel should be created and the pixel immediately next to it should be left as it is. Okay. So with this Gaussian blur function, what we are doing is we are just transforming this image not to have this very sharp edges. Okay, so when we do the inpainting or when we recreate the images in this region, we have the continuity. We don't have the complete contrast from point to point. Okay, around the edges. So we just use this Gaussian blur function, and so basically what it basically does is it takes the nearby pixel values and it tries to sort of smoothen it. So that's why these sharp edges are gone in this image. Okay, but this is optional step, you don't have to do. So we have created the mask, right? So now at this point we have an image and we have a mask with sort of binary values, not exactly binary, but indicating which parts of the image should be inpainted and which parts should not be recreated. Okay, so this function, it takes two images. As you can see here, it takes the image, also it takes the mask. Okay, so the mask is guiding which parts of the image should be recreated. Now the interesting part, the prompt. So the inpainting regions, this prompt is for only the inpainting regions. So only in this case, it happened to be this background, okay, excluding the rocket. So here we are saying rainbow galactic nebula, right? Some star filled sky, some spectral artisan masterpiece, some psychedelic. Okay, but I guess the main thing is this, I guess, the rainbow star filled sky. Okay, so what we are doing is, hey, this is my initial image, this is my mask, which will tell you which parts of the image should be recreated and which one should be left as it is. Wherever we are recreating the image, this is the prompt. Okay, I hope these three things are clear to you, right? And then this is the new image, newly created image. So the prompt, rainbow, star filled sky, spectral, etc., has been applied in this inpainting region guided by the mask. Okay, so quick summary, we started with this image, we have created a mask indicating which pixel should be recreated, which one should not be. For the inpainting region, we have a prompt, we described how it should look like, and we have created a new image. Okay, so creating the mask, it require some good familiarity with NumPy, the pixel values 0 to 255, etc. But it's not too hard. I mean, this part, again, all we are doing is we are taking the original image, we have converted to grayscale, and then we find out a value where we have this clear distinction between the inpainting region and the rest of the region, right? So we use that value to binarize the image, and then we have used some strength value so that how much the inpainting region should be guided by the prompt, and then we scale the image back to 0 to 255. We applied just the Gaussian blur just to have smoothen the edges, and finally we provided the original image, the mask, and then the prompt. So we have recreated the portions of the image. That's why it is called inpainting. Okay, so creating the mask, it involves a bit of sort of mathematics, numpy arrays, etc. But once you figure out how to do it, you can edit the images very easily. Okay. All right. That's all. Thank you very much.